Okay, friends, let's see what we have here. Continuous function f is defined on that interval. Graph of x, f is 2 quarter circles, 1 line segment. G of x is this. Find g of negative 3. So g of negative 3 is 2 times negative 3 plus the integral 0 to negative 3 of f of t dt. So g of negative 3 is negative 6 plus 0 to negative 3, so that's this quarter circle. So the area of that quarter circle, the radius is 3, so the area is 9 pi. It's a quarter circle, so it's going to be 9 pi over 4, but. Since we're going from 0 to negative 3, that's a backwards move, so it's going to be a negative plus negative 9 pi over 3. And then we're asked to find g prime. So g prime is 2 plus the derivative of this. When I do the derivative of the integral, that's the fundamental theorem of calculus, the derivative proportion. Sorry, I forgot how to talk there. So that's f of x. And then use that to find g prime of negative 3. So that's g prime of negative 3 is 2 plus f of negative 3. F of negative 3 is 0, so that is 2. Determine the x-coordinate at which g has an absolute maximum. So, for part B, g has a max when g prime goes positive to negative and at endpoints. I guess I said g could have a max at those places. So, g prime we know is 2 plus f of x. So if I take this graph and I add 2 to it, we're going to have a max right around there. Let's see. So that's, let me write the equation that line. That's going to be plus 3, and then the slope is down 6 over 3, so negative 2x. So if I add 2 to that, that's negative 2x plus 5. So g prime equals 0 when x equals 5 halves, and g prime goes positive to negative. So my choices are absolute max, that's a closed interval. My choices are g of negative 4, which is 2 times negative 4, plus the integral 0 to negative 4 of f of t dt. Another I might calculate that, we'll see. Another choice is g of 5 halves, which is 2 times 5 halves, plus the integral 0 to 5 halves, I don't know why my brain turned off there, of f of t dt. So that's 5 plus, that's going to be this triangle, which hits at 3 halves. So that's 3 halves by 3, so that's 9 halves divided by, so that's 9 quarters. So that triangle is 9 quarters. And then from 3 halves to 5 halves, and then down 3, so that's 1 by 3. So 9 quarters, so plus 9 quarters, minus, that's 3 by 1, so 3 halves. And if I look at g of negative 4, that's less than 0. That's why I said I might calculate that, but I don't have to. Because I know that g of negative 3 is that big negative number up here. So g of negative 4, we're just going to add in that tiny little quarter circle, so I don't need it. And then g of 3 is going to be g of 5 halves minus an additional oh, I messed up. Oh, okay. This triangle here. Okay, so I realized that that's not 3 right there, so let me get rid of that. That's 2, silly. And the reason it's 2 is because if I plug 5 halves into here, I get negative 2 times 5 halves, which is negative 5, plus 3 is negative 2. So it's not minus 3 halves, but just minus 1. Sorry about that. And g of 5 halves minus, and then this little triangle, which is going to be from 5 halves to 3, which is a half, and then from 2 to 3, so that's 1. So that little triangle there is 1/2 by 1, so the area of that is a quarter, so we subtract that part also. So absolute max is absolute max at x equals 5 halves. All right, I'm sure I could have done that a different way, but that's how I chose to do it. Now let's see what we have next. Find point of inflection. So G has point of inflection when G double prime, which equals, well, let's see, G prime is 2 plus F, so G double prime is F prime, changes sign. This occurs at x equals, so I need the slope of f to change sign. So we have a positive slope, and then we have a negative slope, so 0, and then we have a negative slope. So I got 0, because that's f, and then I have to think about f prime. I don't need a comma there, because that is it. And I wrote D, but that was actually part C, sorry. And then for D, average rate of change, that would be for F. F of 3 minus F of negative 4, 3 minus negative 4. F of 3 is negative 3, F of 4 is negative 1. 3 minus negative 4 is 7, so that's negative 2/7. There is no f prime value of that. So that means MVT does not work. Okay, so your justification for that is that f is not differentiable over that entire interval. For example, f is not differentiable. I'm not going to write this all down, but I'm going to tell you verbally. F is not differentiable at 0 because the slope from the left does not equal the slope from the right. Let's see what we have here. The rate at which people enter an auditorium for a rock concert is modeled by that function. No one in the auditorium. So no one in the auditorium at the beginning. Doors close at 2. How many people are in the auditorium when the concert begins? So the concert begins at 2. So that's the integral 0 to 2 of r of t dt. And we just need to calculate that. And I get 980 people. And so that's just a calculator piece on that. And then for part B, find the time when the rate at which the people enter the auditorium is a max. So that's the rate that people are entering. So we need to know, find the time when the rate when people enter the auditorium is a max. So rate is max when, so I need to know when the rate is a maximum. So I need to know r prime of t is, actually I just need to know when r prime is equal to 0. So I can use my calculator for that also. I could find the derivative by hand if I needed to and just put that into the calculator. Figure out when r prime is 0. I can use my calculator for that. And that occurs, I don't need the calculator for the first part, 0, and then the second part, 1.36 I don't know, 3. Make sure you use that exact value if you're using a calculator. So then I need to know r of 0. I know that, that's 0. And then I need to know r of 1.363, which is somewhere around 854.527. I'm just plugging that in. And then r of 2, because I got to check endpoints, is 120. So the time at which the rate is at a maximum, rate is at a max when t equals 2. And now for part C. It says the total wait time for all people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium, and ending when the concert begins. The function w models the total wait time for all people enter the auditorium. Derivative of w given by w prime is 2 minus t r of t. Find w of 2 minus w of 1, the total wait time for those who enter the auditorium after t equals 1. So I want to know what w2 minus w1 is. Well, let's see. If I think about kind of what I did in part A, if I integrate from 1 to 2 of w prime of t dt, that gives me w of 2 minus w of 1. And since I know what r of t is, I can just put that in my calculator, push some buttons, and that will spit out what the answer is. So if you've already put r of t in for y, you can just do 2 minus x times y, and you can integrate that. And if you do that, you should get 387.5. So the context of that is people wait a total of 387.5 hours. Well, people who enter after 1. So people who enter after 1 wait a total of 387.5 hours. It sounds like a lot, but if there's a ton of people there, it's not that much time, like the 980. Okay, on average, that's part of what this is getting to. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. So that's going to be, okay. So that's going to be total wait time over 2 hours. So that's what I need to find. Now the total wait time, this got me the wait time from 1 to 2. So the total wait time is 0 to 2 of w prime of t dt. Then I have to divide that. Oh, not by 2, that's silly. Not by 2. Total wait time, that'll give me the wrong units. Total wait time over how many people? How many people? So that's going to be 0 to 2 w prime of t dt divided by 980. So if I do that, again, that's a calculator question, then I get 0.776, which in the context of this question, a person waits 0.776 of an hour on average. Now, it might seem like a lot, but that's like 3/4 of an hour, which is like 45 minutes. So that's not a huge amount of time. Let us see what this next question brings us. Ooh. On the axis provided, sketch a slope field. So, okay, I can do this. If y is 1, then this is 0. So then the slope is 0. So if y is 1, the slope is 0. And then if y is 0, then that quantity is 1. So let's see, the cosine of 0 is 1. The cosine of pi is -1. Cosine of negative pi is also -1. And then when I'm down here, if y is -1, then that quantity is going to be -1 minus 2 squared, so 4. So it's going to be the same idea, but steeper. So 4, -4, -4. There is a horizontal line with equation y equals c that satisfies the differential equation. Find the value of c. Okay, that sounds super scary, but look at the slope field. The slope field has a horizontal line at 1, so it's just y equals 1. That's all we got to do. So that came from the work we did in part A. Now for part C, find a particular solution. Okay, so for a particular, actually I'm going to shrink this over here. For part C, the original equation was this one. So if we separate the variables, that's got to be your first step. dy over y minus 1 squared equals cosine pi x dx. And I'm going to rewrite the left side as y minus 1 to the negative 2 dy. And then I'm going to think about the right side. So that's cosine of pi x dx. We're going to integrate that. If you need to, go ahead and u sub it. So u is pi x. So du dx is just pi, which means dx is du over pi, if we do the algebra. Which means we got the cosine of u du with 1 over pi in front, not 1 over u, 1 over pi. So that's a long way of saying that I have 1 over pi integral cosine u du. And my next step is going to be to find the antiderivative, or the underderivative. So y minus 1 to the negative 1. Oh, but I need a negative there, because when I take the derivative, the negative 1 comes down, makes it a positive. And then we have the y minus 1 to the negative 2. Whose derivative is the cosine? Well, that's the sine, of course, of 1 over pi. I'm going to go ahead and jump back to x's right now, because I feel like it. And don't forget plus c, because I found the underderivatives. I know that when I plug in 1 for x, I get 0 for y. I'm going to find that right now. So I get 0 for y, so that's 0 minus 1, which is 0. Try again. 0 minus 1 is negative 1, to the negative 1 is negative 1. And then the sine of 1 pi, the sine of pi is 0, plus c. So that means c is 1. So we have negative y minus 1 to the negative 1, 1 over pi sine pi x plus 1. And let's go ahead and take care of those negatives, shall we? So put a plus there, put a minus there, put a minus there. And then y minus 1 to the negative 1, maybe I'll write this step for you. So it's 1 over y minus 1 equals 1 over pi, negative 1 over pi, sine pi x minus 1. So I'm going to multiply by y minus 1, and I'm going to divide by negative 1 over pi sine pi x minus 1. And to finish, all I need to do is add 1. So 1 over negative 1 over pi sine pi x minus 1 plus 1. And that is equal to y. And we have done it.